Hi students, welcome to today's class. Today I am going to explain a application of derivatives chapter. Under that one sub chapter, that is derivative as rate measure. Derivative as a rate measure. So this is also very important concepts for your next oncoming April JEE mains examinations. Okay. Now, what is a derivative as a rate measure? We know what is a derivative. So, derivative of a quantity, differentiability, derivatives, all those things we have learned. So, let us see that what is derivative of a quantity with respect to another quantity. Let us see here. Let us take y and x are any two quantities, displacement, time, height, pressure, like that. Time, displacement, velocity, acceleration, otherwise distance, time, pressure, height, like that. Okay, now let us do quantities. First one. Second one, let y varies with x and depends on x. Understand? So the quantity y varies with x. As x varies, y also varies. And y depends on x. The change of y depends on the change of x. Okay, if such quantities are there, they are not independent quantities. Now, from that, what can say? So, the y varies with x and y depends on x. Then, the rate of change of y with respect to x is denoted by or given by dy by dx. The rate of change of y with respect to x is denoted by dy by dx. Okay, na? So let us take one example. Pressure and height. So we know that as we go on, as the height increases, pressure also increases. Pressure, of course, maybe increase or maybe it depends upon the pressure also, it depends. So the rate of change of pressure P with respect to height H is denoted by dP by dH. And another best example is the rate of change of displacement S with respect to time t. The rate of change of displacement S with respect to t is given by ds by dt. The rate of change of displacement S with respect to t is denoted by ds by dt. This is called it as a velocity. Okay, na? That means the displacement depends upon the time. Then we call it as this quantity ds by dt is called velocity. Again, the rate of change of velocity, that is with respect to time. The rate of change of velocity with respect to time is called as a acceleration. Okay, now. So depends upon that. That means what? From this, what can you learn? Y and x are two quantities. Let y varies with x and y depends on x. Y varies with x. That means as x changes, y also changes. So, and it depends on x. Then the rate of change of y with respect to x is denoted by dy by dx. Okay, now. So, examples, the rate of change of the pressure P with respect to height is denoted by dP by dH. The rate of change of displacement S with respect to time, this is called ds by dt. We call it as that quantity as a velocity. Again, the rate of change of velocity with respect to time, the rate of change of means with respect to time. So, here one more important point is, very important point is, the rate of change means d of something by dt, by dt. The rate of change means with respect to time. Understand? So that is the, if it is given, the rate of change if it is given with respect to time. Okay, now. So I hope that you understand very small quantity. If you go for in physics, so there are so many concepts will be there on this velocity, acceleration, rate of change. But in our mathematics, so this type of some quantity, some basic information is enough to do the problems. Okay, so let us do some problems based on this concept. Welcome to this problem. Displacement S of a particle at a time t is expressed as S is equal to 1 by 2 t cube minus 60. 1 by 2 t cube minus 60. Find the acceleration at that time when the velocity vanishes. When the velocity vanishes means what? Velocity will become vanish means become 0. Let us see that we have to find out the acceleration when the velocity will become 0. First find the velocity. So as a displacement is given 1 by 2 t cube minus 60 displacement. We know the velocity, already we explained. What is velocity? The rate of change of displacement. The rate of change of displacement is called velocity. That means velocity is equal to the rate of change of displacement. That means we have to differentiate the function s with respect to t. So this is equal to how much? 1 by 2 3t cube 3t square minus 6. So this is equal to, so no cancellation. So this velocity vanishes. That means is equal to 0. Velocity vanishes. Let us find out what happens here. 3t square minus 12 is equal to 0. So 3t square minus 12 is equal to 0. Therefore, t square is equal to 4. Therefore, t is equal to 2. So at t is equal to 2 or maybe seconds or minutes, the velocity vanishes. The velocity of the particle, that means once it started after 2 seconds or 2 minutes. So it is time is not given. So after 2 seconds or 2 minutes, so or whatever 2 hours, the velocity of the particle vanishes. Now we have to find out the acceleration. Okay, now what is velocity is given? So velocity is given by 3 by 2 t square minus 6. 3 by 2 t square minus 6, that is the velocity. Then how to find out acceleration? The rate of change of velocity is called acceleration. So a is equal to dv by dt. So 3 by 2 into t square means 2t. 2 cancel 3t. 3 into 2, that is 6 units per something second square or whatever may be the time square. Okay, now. So therefore, acceleration is equal to 6 units. So this is a very basic level problem. So for your understanding purpose, I explained. So let us see some more problems. Welcome to this second problem. On the curve x cube is equal to 12y, find the interval of values of x for which the abscissa changes at a faster rate than the ordinate. At a faster rate than the ordinate. That means what? There is a curve like this. There is a curve. On the curve, there are infinite number of points are there. There is a particle is moving like this. Okay, now we have to find out a interval. We have to find out a interval. We have to find out a interval of x in which interval of x for which the abscissa changes at a faster rate than the ordinate. Abscissa, that means what? Here point is there, x comma y. So as the particle moves on the curve, the coordinates of x and y are also changes. Okay, that depends upon the curve. Understand? So now we want an interval in which the abscissa means x changes at a faster rate than y. That means what? Solution. So dx by dt, that means the rate of change of x, the rate of change of x should be greater than the rate of change of y. This can be written as dx by dy greater than 1. Of course, modulus. Why? Because here the change, the positive change only, not the negative change. The rate of abscissa should change at a faster rate than the other. So dx by dy greater than y. Now what is dx by dy? Let us see here from this x cube is equal to 12y. Differentiate this equation with respect to y. So, this is equal to 3x square into dx by dy is equal to 12. Understand? With respect to y we are differentiating. Therefore, dx by dy is equal to 4 by x square. Dx by dy is equal to 3 1s are 3 4 by x square. So, this implies 4 by x square greater than 1. 4 by x square greater than 1. Definitely x is not equal to 0 as it is denominator. So, let us find out this inequality. Therefore, x square by 4 less than 1. X square by 4 less than 1. Therefore, x square is less than 4. So, modulus of x square is x square only. So, this implies we can say that x plus 2 into x minus 2 less than 0. That means x lies between minus 2 and 2, but x should not be equal to 0. X should not be equal to 0. Therefore, in which interval? So, x should belongs to open bracket minus 2 minus plus 2, but should not be equal to 0. So, in this interval, in the interval when x is between minus 2 to 2, except 0, when x is between minus 2 to 2, at that time the rate of change of x will be faster than the rate of, that means when a particle moving from minus to, when it enter into minus 2 to 2 except at 0, the rate of change of x coordinate will be faster than the y coordinate. Okay, now, right. So, very easy problem this is. So, this type of problems will be asked in JEE mains examination. Okay. I hope that you understand this solution. Let us move one more problem. Hi decreasing welcome to this problem. The length x of a rectangle is increasing at the rate of 5 centimeters, decreasing at the rate of 5 centimeters per minute, and the width y is increasing at the rate of 4 centimeters per minute. When x is equal to 8 centimeters and y is equal to 6 centimeters, find the rate of change of the perimeter and the area of the rectangle. So, basically there is a rectangle is there. Okay, now the length it is denoted as x and the breadth is y. First one, the length x of a rectangle is decreasing at the rate of how much? 5 centimeters per minute. So, this length is there now. It is decreasing 5 centimeters per minute means what? For every 1 minute 5 centimeters is going on decreasing. That means what? Dx by dt is equal to minus 5 centimeters per second. Why we are writing minus 5 means it is decreasing. And the y is increasing at the rate of 4 centimeters per minute. So, the width y is increasing 4 centimeters per minute. That means what? dy by d is equal to 4 centimeters per minute. It's going on simultaneously. That means the length is decreasing, the width is increasing. The length is decreasing 5 centimeters per minute, and the width is increasing 4 centimeters per minute. So, definitely its perimeter will change and the area also will change. We have to find out the rate of change of perimeter. That means what? We have to find out dp by dt, the rate of change of area of the rectangle, dA by dt. Okay, now, right. So, let us do the solution. Next, we know that perimeter of the rectangle is 2 times length plus breadth, x plus y. So, this is equal to dp by dt is equal to 2 times dx by dt plus dy by dt, the rate of change of perimeter. So, this is equal to 2 times dx by dt means how much? Minus 5. dy by dt means how much? 4. Minus 5 plus 4 how much? Minus 1. This is equal to minus 2 centimeters per minute. That means what? The perimeter decreases. The perimeter decreases 2 centimeters per minute. The perimeter decreases 2 centimeters per minute. Okay, now. This is the first one. Coming to second one, area, length into breadth. Area is equal to how much? Length into breadth. So let us find out dA by dt, the rate of change of area. So this is a by parts formula, u into v. So therefore x into dy by dt plus y into dx by dt. So x value is already given. How much? 8 centimeters. So 8 into dy by dt. So dy by dt is equal to how much? So it is given that dy by dt is equal to 4 plus y into. So y value is given as a 6 into dx by dt. So dx by dt is equal to how much? Minus 5. This is minus 5 dx by dt. So 8 4s are 32. 6 15. 30, 6 5s are 30. So this is equal to 2 centimeters per minute. That means what? The perimeter decreases at the rate of 2 centimeters per minute, whereas the area increases plus 2 centimeters per minute. Okay, plus we got. So we got here 2, it is increases at area increases 2 centimeters per minute. So okay, so very easy problem, very basic level problem this is. So I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. So one of the important model this is, let x be the length of one of the equal sides of an isosceles triangle. So first of all, there is an isosceles triangle A, B, C, equal sides. So these two are equal. Let us take AB is equal to AC, equal sides, and theta be the angle between them. So definitely this is the theta, that means not this, not B and C, angle between these equal sides. Okay. If x is increasing at the rate of 1 by 12 meters per hour, so that means what? This x, the side is increasing. That means dx by dt is equal to given as 1 by 12 meters per hour. It is increasing. And theta is also increasing at the rate of, so d theta by dt is equal to pi by 180 meters per, radians per hour. So radians per hour. That means what? X is increasing. Theta is also increasing. Both are increasing. Sides are increasing. Theta is also increasing. Then what happened? Automatically the area also increasing. So we have to find out dA by dt is how much? The rate of change of area. Okay now. So let us how to do this. So first of all, we know that from trigonometry point of view. So what is the area of the triangle is equal to half x square sin theta. Half into AB into AC into the angle between included angle AB, AC included angle theta. That means half into AB into AC into sin theta. That means that is the value. Now we have to find out dA by dt. So let us take first 2a, write down 2a is equal to x square into sin theta. Let us find out dA by dt, differentiate this with respect to t. So we want to find out dA by dt, the rate of change of the area. So 2 times here dA by dt is equal to x square, differentiate with respect to t on both sides, x square into sin theta derivative cos theta, again theta d theta by dt plus sin theta into x square derivative 2x into x derivative dx by dt. Okay. So we know all the values here. So here x square, x is 12, this is a 144, cos theta, cos pi by 4, 1 by root 2, d theta by dt, that is a 1 by pi by 180, sin 45, 1 by root 2, sin 45, theta pi by 4 given. So 2 into x value 12, dx by dt is given as 1 by 12. So everything is clear. So this is 2 times dA by dt. Any more cancellations? Here 12 cancel. 2 144 2 can be cancelled. Therefore dA by dt is equal to 72 by root 2 into pi by 180 plus 1 by root 2. Okay now, right. This is a 36 2s are 36 5s are. Okay. So this is equal to 2 by root 2. So we can write down it as a root 2 pi by 5 plus 1 by root 2. Okay now. So this will be the final answer. Otherwise you can take a root 2 common outside. If you take a root 2 common outside, this is a pi by 5 plus 1 by 2. Understand this? So root 2 into pi by 5 plus 1 by 2, that much the rate of change of area when both x and theta changes. Okay. So I hope that you understand this solution. Welcome to this type of problem. A ladder 5 meters long standing on a horizontal floor leans against a vertical wall. That means if the top of the ladder slides downwards at the rate of 10 centimeters per second, then find the rate at which the angle between the floor and the ladder is decreasing when the lower end of the ladder is 2 meters away from the wall. Total, this is a ladder problem. So what the ladder means here? So here there is a horizontal and it is a wall. Here there is a ladder. So here there is a ladder. This is a ladder. It is a 5 meters long. 5 meters means, see here it is given in centimeters. Again it is given in meters. Let us brighter, you convert total into centimeters. So 1 meter is equal to 100 centimeters. Therefore 5 meters is equal to how much? This is 500 centimeters long. 500 centimeters. Okay. Right. Standing on a horizontal floor leans against a vertical wall. If the top of the ladder slides downwards at the rate of, so the top of the ladder slides down, it is sliding down, automatically this bottom of the ladder also will go away of this wall. Angle between the floor and the ladder is decreasing. So this is the angle between the floor and when this ladder, top of the ladder slides down, this theta is also go on decreasing. Understand? It depends upon this y values. This theta depends as how much it is decreasing, means it depends upon this y value. Okay na? Then what is the rate? Find the rate at which the angle between the floor and the ladder is decreasing. That means on the whole we have to find out d theta by dt. That is the value we have to find out. How much it is decreasing. Okay now, let us see this for our convenience. Let us take it as a cos x value and it is a y value. Okay now. So from this what is cos theta? Cos theta is equal to x by 500. Sin theta is equal to y by 500. Sin theta is equal to y by 500. Therefore x is equal to 500 cos theta, y is equal to 500 sin theta. Okay na? 500 sin theta. Again, then if the top of the ladder slides downwards at the rate of 10 centimeters per second, that means what? dy by dt is equal to 10 centimeters per second. It is given. It is sliding downwards. Dy by dt is equal to, it is at which the downwards at the rate, the slides down. That means what you have to ladder? Minus you have to write down. Then find the rate at which if the top of the ladder slides downwards at the rate of 10 centimeters per second. So dy by dt is equal to minus 10. Okay now. Now here where is y? Here y is there. So here y is equal to 500 sin theta. Therefore dy by dt is equal to 500 into sin theta derivative cos theta, again d theta by dt, again d theta by dt. Okay na? Right. So dy by dt is equal to how much? Minus 10. This is a 500 into cos theta. So cos theta value is equal to how much from this? Cos theta is equal to how much? X by 500. Cos theta is equal to how much? X by 500. X by 500 into d theta by dt. Okay. Again, see here x by 500, 500 will cancel. Minus 10 is equal to x. See the. And the ladder is decreasing. The lower end of the ladder is 2 meters. This lower end 2 meters away from the wall. That means what? X is equal to 200 centimeters. 2 meters means 200 centimeters. So this is equal to 200 into d theta by dt. Okay na? So any more cancellations? One will go. So d theta by dt is equal to minus 1 by 20. What we call it as a radians. Any angle is given, no units are given. Therefore, we can call it as a degrees per meter or radians per meter. So d theta by dt is equal to how much? Minus 1 by 20. That means the rate of change of this angle is 1 by 20. It is going on decreasing 1 by 20. Okay. So I hope that you understand this solution. So you enjoyed today's class, and tomorrow's class with some more problems. Tomorrow I will stand before you. So until then, all the best.